Okay, so this problem is called Network News, and it says that the Pew Research Center claims that more than 55% of adults regularly watch a network news broadcast. It sounds pretty high to me in the day of internet, and the World Wide Web and what. But at any rate, okay. So 55% of adults regularly watch a network news broadcast. If in a random sample of 425 adults, say 255 respond yes, I guess yes that they do watch a network news broadcast, is there enough evidence at the 0.05 level of significance to support the claim? All right. Okay, so what kind of problem is this?
So we say more than, so it would be a right-tailed test.
But in terms of the kind of problem it is,
Oh, a hypothesis.
yeah, it's a hypothesis test because they're talking about claims, right? One way you can tell it's a hypothesis test is someone's trying to establish a claim. The other way you can tell is it's talking about a level of significance. So see this stuff over here where they're talking about 0.05 level of significance. Another name for a hypothesis test is a test of significance as well. All right, so it's a hypothesis test, and the stuff you have to deal with when you're looking at a hypothesis test is what? What do you have to set up?
You have to set up one of the the charts.
You mean?
Oh, the equation?
No, I'm talking the two hypotheses that you have to worry about.
Oh, the null hypothesis?
Yeah, the null. And that's H0. And what's the other one called?
The alternate hypothesis.
Yeah, that's right. Okay. So H0 and HA. And this is the null hypothesis, and the HA is called the alternative hypothesis. All right. Now, how do you set up the null hypothesis for a hypothesis test?
You would say that it would be 0.55.
Yeah, you're looking for the population proportion, and you're looking for a claim about the population proportion, right? And here the Pew Research Center claims that more than 55% of adults regularly watch a network news broadcast. So that's got to be the population proportion that's in question, this 55%. Okay, so for the null, what we're going to do is we're going to set that theta equal to 0.55. Okay, so the null hypothesis always has this form right here. It's that the population proportion is equal to some value. And then the alternative is either that the population proportion is bigger than this value, or is smaller than this value, or is just different from this value. And we kind of have to figure out which of those to use down here based on what it says. So up here in the problem it says that the Pew Research Center claims that more than 55% of adults watch a network news broadcast. So that means the alternative has to have what form? Theta is what?
Is greater than.
Yeah, greater than this 0.55. Yeah, good. All right, so let's see. Now what else are they giving us here? They're giving us this 425. So they're talking about a sample, and they say the sample of 425 adults, out of those, 255 say that they do watch a network news broadcast. So this 425 has got to be what?
That's n equals 425.
Then what's n called? What's that called?
That's the sample.
Sample size.
Yeah, right.
Yeah, sample size. Okay, so the sample size is 425. And then this, what is this 255 telling me about?
That's the statistic that we're trying.
Yeah, that's right. It's part of the test statistic, which means it comes from our sample. And in this case, for our sample, we're computing what? We're computing that, what's that thing called? The sample proportion, right? And the sample proportion is p hat. And how do I compute p hat?
You would 255 over 425.
Right. So I put the 255 that say they do watch a network news broadcast on the top, and on the bottom I put my whole sample size. Okay, and what does that equal to?
0.6.
0.6. Okay, good. All right, so let's draw a picture of what this stuff looks like here. So we'll draw the p hat distribution here, and we know that when we do calculations here, we're going to be changing those guys into z-scores. So let's draw z over here as well too. All right, now in the middle of the p hat distribution, I have what?
We want to put 0.55.
That's right. That's the population proportion we're trying to test. And then that corresponds to what over here is a z-score?
0.
That's right. So this is 0 over here. Okay, and then our sample proportion is this 0.6, and so where do I put that in regards to this 0.55?
Just pretty close to 0.55 on the right side.
So over here to the right of it, right? So 0.6 right there. And that means that the z-score I get is going to be over here somewhere as well for it, right? Now, if this is, if our alternative hypothesis looks like this, where theta, we're trying to test for the alternative that theta is bigger than 0.55, then it's what kind of test?
It'll be a right tail test.
Yeah, it's right tail, because this is bigger than the population proportion. So I'm looking at the tail over here to the right of my test statistic, and that means over here for the z-scores, it's going to be this tail over here as well, too. And in this case, this area right here is called a p-value. Okay, so once we find this z-score over here, we'll be able to look up this area in the table, and that would become our p-value. And then based on our p-value, we'll decide whether we reject or fail to reject the null hypothesis over here. Okay, so how do we get from this p-hat, the 0.6, to the z-score?
We want to do a table lookup, right, and find 0.6.
We do, but we don't do the lookup. Yeah, I think you're jumping too far ahead.
The equation that we want to do?
Exactly. We do the lookup after we have the z-score, but I think before we do the lookup, we got to change that p-hat into a z-value. Do you remember how that goes? So yes. Z is what?
Z is equal to 0.55. Right?
Well, that's in there, but in terms of words, do you remember what the z-score is in terms of words?
What is it, the mean?
Yeah, minus that's part of it. It's minus the mean. That's the second part of the top. What's the other part of the thing that goes on the top? Do you remember?
The data value?
Data? Yes, it is data. That's it. So it's data value, whatever that is, and that's going to be this p-hat over here. And what goes on the bottom?
Size?
Not the sample size.
Or the population, like the 425.
No, that's the sample size. Oh. It's not that. It's the standard deviation.
Standard deviation.
Okay, that's the formula, right? It's the data minus the mean over the standard deviation. Okay. Now, in this case, like you said, the data is going to be this value over here, the 0.6, right?
Right.
Minus the mean is going to be what?
0.55.
That's 0.55. And how do we get the standard deviation?
You have to do the square root.
Yeah, that's it. That's what you're remembering a minute ago when you're remembering that formula. You're remembering part of this formula. It's the square root of what? Right. Do you remember what goes on the inside?
So I know in the brackets it's 1 minus.
Yeah, that's right.
0.55.
Yeah, there's a part right here that's 1 minus that. Yeah.
And then 0.55 is over.
Yeah, that's right. Okay, so this is the population proportion here, and then 1 minus the population.
425.
Yeah, that's the sample size, right? Good. All right, so give me that. So I need 0.55. I'll write it again here. I need 0.55 times 0.45 divided by 425. And then when you're done with that, I need a square root of that whole thing.
Wait,
so underneath there, you're getting 0.00058,
so
right?
0.024.
Oh, okay, that sounds right. 0.024. Okay, good. So let's put that in up here. 0.24. Right. All right, you're using my calculator is the problem. That's what it is. 0.6 minus 0.55
equals divided by. Equals 2.08.
That sounds about right.
And that's what we look up in the table.
That's it, because that's going to be the z-value, right?
I see.
Okay, so let's write it in over here. So that's going to be 208. Now wait a minute. Before you look up it in the before you look it up in the table, let's figure out what we're looking up in the table. Okay. I'm trying to find the area to the right of that z-value, right?
Right.
So if I'm trying to find the area to the right of that z-value, how do I get that? I know the table gives me which area?
The table gives you the z-score.
No, it gives you the area based on the z-score.
Okay.
But it gives you the area from the left-hand side all the way up to the z-score, right?
And we want to find the right-hand side.
Yeah, and how do we get that?
Oh, we have to do 1 minus.
Yes, exactly. That's it. That's it. You got it. All right, now it's there. Good. All right, so the z-value we're going to be looking up is 2.08. So go to the table.
And it is. Can we just do this? 0.9812.
Okay, so it's going to be 1 minus 0.9812. Okay, so give me that. It's 1 minus 0.9812.
0.0018.
0.0108?
No, 0.0188.
Okay, wait a minute.
0.0188.
Oh, okay, good. All right, so that's the area to the right here, and that is going to be our p value, right?
Right.
Okay, so for a right-sided tail, you don't have to do anything more to the p-value. It's just the area of the tail to the right of that z-score. For a two-tailed test, you have to add the area on both sides, but for this part, at least we're fine. Okay, so if the p-value is 0.018, then we can figure out whether to reject or not the null hypothesis by looking at the alpha level now. Okay, so the alpha level for this problem is 0.05.
Right.
So we look to see whether this p-value is smaller than that 0.05, and is it?
Yes.
It is. Okay, so if it's smaller than this alpha over here, then that tells us that we reject the null hypothesis, H0, and also people sometimes say the result is significant when that happens.
The result is significant?
Right. So we say we reject H0, and the result is called significant.
Okay.
And let's see if we can figure out what it was we just rejected up here. Okay. So the hypothesis was, the null hypothesis was that the population proportion was equal to 0.55, that that many adults really watched a network news broadcast. And the alternative, though, was that theta was bigger than 0.55. The population proportion was bigger than 0.55. And since we've rejected the null hypothesis now, we've sort of decided in favor of this alternative. And that's what the Pew Research Center was claiming, was that actually that more than 55% of adults watched network news.
Right.
So we sort of established their claim, actually. In this case, the claim from the Research Center is this second one, corresponds to the alternative.
So we're saying, yes, they do watch more than 55. More than 55 adults watch
Exactly.
network news. Okay.
Exactly.